If you still not subscribe my channel, so please subscribe my channel and press the bell icon button to get notification firstly of my upcoming videos.
In the DC-DC converter circuit shown, switch Q is switched at a frequency of 10 kHz with a duty ratio of 0.6. All components of the circuits are ideal and the initial current in the inductor is 0. Energy is stored in the inductor in millijoule at the end of 10 complete switching cycle is. So it's a difficult one question. Almost one leave this question in the examination hall. So first of all, before solving it, we have to analyze the circuit. What will happen inside the circuit? So firstly, we see that the 50-volt battery is directly connected to this inductor via the switch Q. And after that, this diode is connected in inverted manner to this battery across this inductor. Okay. Now, some information is given in the question like switching frequency. Fs equal to 10 kilohertz means we can determine time period from here. Ts is equal to 1 by Fs means 1 by 10. So we get 0.1 millisecond Ts. Okay. Duty cycle is also given in the question. 0.6. We know that the formula of duty cycle alpha equal to T on by T. The value of T on we don't know. That's why we can write T on equal to alpha into T. So the value of alpha is 0.6 times 0.1. We get 0.06 millisecond is the T on time. It's all about 60%. So we can say T of period will be 40% means 0.04 millisecond. Okay. Now, during T1 period, what will happen? During T1 period, the current flow in this manner. Okay. Current doesn't flow in this circuit because the reason behind it, this positive terminal is directly connected to negative terminal of the diode. That's why diode will remain in off condition during T1 time. During T1 time, diode will remain in off condition. Okay. Now we can write V equal to L di by dt. So we can write from here di equal to V by L dt. Integrate both sides. We get del I equal to V by L T on. Okay. Substitute the value V equal to 50 volt. The value of L is 10 millihenry into T on 0.06 milliseconds. Milli cancel out, 0 cancel out. We get 0.3 ampere is the current. Okay, during T on. Now we get del I equal to 0.3 ampere, okay, during T on period. Okay, now we have to consider during T off. During T off, switch is closed, means there is no current flow in this circuit. Now what will happen? As the switch is closed, the polarity of inductor reversed. Now this voltage dominates. That's why the polarity of this will be more positive. The diode will be on. So this is the phenomena will happen here. Due to this polarity of positive, that's diode will be on. Okay, so the current flow in this manner, means the inductor discharge via this path. Okay, so we can write equation for this circuit. V equal to L di by dt. Okay, so di equal to V by L dt. Integrate both sides, we get same equation as earlier. Del I equal to V by L T off, because we are talking about T off period. Okay, substitute the value. V equal to 50 volt, value of L is 10 millihenry, T off is 0.04 millisecond. Milli cancel out, 0 cancel out, we get 0.2 ampere current. Okay, during T off. Now if we plot the graph, we found that this is the peak to peak current, means I max minus I min equal to 0.3 ampere, means initially there is no minimum current, means minimum current is 0. You can say I max is equal to 0.3 ampere. Okay, so initially the current rise from here to 0.3 ampere, somewhere here 0.3. Okay, now this is T on period. Okay, after that this is also peak to peak current, means T I max minus I min equal to 0.2. Okay, so now here the current decrease up to 0.2 ampere, means the difference between these two is 0.2. Okay, this time is T off. So here is one cycle is complete, T time. After that, the minimum value is 0.1. Okay, so substitute here 0.1, then this minus 0.1 goes to this side and get 0.4. So the maximum value will be 0.4, means it goes to somewhere here. This value is 0.4 because 0.3 ampere, 0.4 ampere, in 0.1 the 0.3 equal to 0.4 ampere. Now the current decrease up to what level we have to find from here. Now the maximum value is 0.4 minus minimum value equal to 0.2. So put the value here. Maximum value is 0.4. So 0.4 minus I min equal to 0.2. We get the value of I min equal to 0.2 ampere, means the current decrease up to 0.2 ampere. 0.2 is somewhere here. Okay, this is T on, this is T off, this is 2 cycle is complete. Here up to 2T, 2 cycle is complete. Okay, now the patterns look like this one. One interesting point is here, at time t 0.1 current is reached, at 2t 0.2 current is reached. Okay, at 3t 0.3t 0.3 current is reached. So we can say at 10t 1 ampere current is reached. Got it? At 1t 0.1 ampere is reached, at 2t 0.2 ampere is reached, at 3t 0.3 ampere is reached, at 10t 1 ampere is reached. Okay, so we find the value of I. After that we have to calculate it, the energy. So we know that the formula of energy is stored in the inductor, E equal to half Li square. So half the value of L is 10 millihenry equal to value of I is 1 ka square. So 2 5s are 10, E equal to 5 millijoule is the answer of this question. Okay.